We are working on something entirely new today. We're working on an ESR meter. What is an ESR meter? It reads capacitors and sees if they're bad in circuit. What's wrong with this one? It has battery corrosion. Rust, I think. Possibly. Maybe just some bad corrosion. Who knows? We'll see. Now, this thing actually does power off of micro USB, but the problem with micro USB is I don't want to buy a new cable and I don't know where any of them are. So we may be addressing that as well today, but we shall soon find out. So it would be nice to have this thing to actually get it to where I can use it, because I've not successfully used this yet. Now, before we continue with anything else, I do want to make sure that it is known that I am not a professional nor an expert. I am teaching myself how to repair things and all about electronics, circuitry, components, and all the rest. So I may say things that are completely wrong, do things the least efficient way, and possibly get things wrong all the time. Who knows? But I shall endeavor to learn, grow, and adapt, and figure things out as we go. So just take this as a tutorial video, but rather just as an entertainment video and, you know, trying to figure things out as we go. So, how do we get these battery contraptions out? So, I was trying to say battery terminals, but that was not coming out. These are usually, there's two ways that these go in here. So usually it's either metal connectors that they just push in and there's just a friction fit, or there are wires connecting from the terminals to somewhere else of the device. So the first thing we're going to have to do is unscrew this case and take it apart, and hopefully and pray that this does not go horribly wrong. There we go. And it just pops up. Okay. Got something soldered in here, which is the probes. And then we've got our battery terminals are soldered in, and these ones are just held in place. Don't think there's any way we could do this without unscrewing this portion. So let's go ahead and unscrew this motherboard. Let's go ahead and unscrew this top two. Oh, we'll go into star pattern. Why not? I'm sure this makes sense to somebody. There we go. It's coming free. We pull this thing out straight. Yes. And now we got... Oh, very cool. Okay, so we've got a, I think these are called JST connectors. This one's a little beefier than the puny ones we got. Pop this off. Perfect. I like that setup. We can pry these up and pry these up, I guess. Let's see. Can we just, push these up? And then will they have enough room to go down is the question. It's going to be dicey. I might need some pliers here. It's going to be... Oh, no, we won't be able to do that, will we? Because this is going to be in the way. Intelligence. I should have thought of that before this. Okay, so we can't do that. So we're going to have to desolder this unless we just want to leave it in there. Can we remove this thing and then... Yeah, let's go ahead and remove this this thing. Can we? Can we remove you? Oh, that's got a lot of it. Okay, there. Oh. Of course it came off. That's okay. It's okay. We're all right. We're all right. Thought that would have been a little easier to pull out. So let's go ahead and bend this back. We're just going to submerge this whole thing from the bottom in vinegar. And now hopefully that'll work. So yeah, we'll do that. Now, got this little, not disposable, but collapsible painter's cup from the Dollar Tree. So we'll just go ahead and expand this, and this will be perfect. And I think... Yep, and it'll fit perfectly in there, and we'll just go ahead and submerge the contacts and let that sit for, I don't even know, maybe a half hour to an hour? You guys think that'd be enough time? Or do we gonna need some crazy amount of time, like a day or so? But we'll see, who knows? Oh, this stuff is actually expired by a couple of years. No, 1 year. Never mind, only 1 year. It's 2025. All right, that's okay. I'm sure it'll be good. We're not drinking it, so okay. Beautiful. Smells like Easter. Doesn't smell quite as potent, so who knows? Maybe it's not enough. Maybe we need some fresher stuff, but it is having a reaction, so I like that. It's pretty cool. Let's take our attention to this stuff here. So we've got our port. Now, it would be very cool if we could switch this port out for a USB-C port. Now, the way we would be able to try to do this would be using these. Got these USB-C breakout boards here, and these ones are pretty simple. They can have data lines, but these ones, you know, if you're just charging it, really you only need voltage and ground. So I think these two center pins are data plus and minus, if I'm correct. I'm not 100% sure. I think this is voltage. And I think if you wanted to have data, you would have to move this resistor or add a resistor or something. I'm not entirely sure how exactly it works, but yeah, and this is a female USB-C, so you'd be able to plug in a lead into here. And this, in theory, would replace this port here, which could make some sense. Now, also, this isn't quite large enough to fit this in here. So we would have to grind that out, I think. So we got some ideas of how to do this. Now, I've actually had some experience with USB-C breakout boards and actually using them to charge things. But there's a little bit of a sad story along with this. This is a DSi XL, and I added USB-C charging to it, which is right there. Save your applause, because inside of here, I used a JST connector, one of those mini ones that I accidentally purchased, and I hooked up one to the side here and then glued it down, and everything works. It actually charges. However, I messed up on this. So it's you know, it's the flex ribbon cable for the volume and the trigger button, and I tried 3 or 4 times to try to get it to work. Soldered from here, soldered to here, soldered to there, to here, and here, and here, and it still wouldn't work. And unfortunately, these things are pricey on the used market, about $20 for this part alone. And it's also one of those things that AliExpress does not carry. And the replacement DSi XL is like $60 even if it's broken. So yeah, this didn't work out great. Also, I lost the recording for this entire thing. And yeah, I had everything recorded except for, you know, maybe fixing this or replacing it. But yeah, that's how it goes sometimes. So yeah, so I have some experience of how to get this all hooked up. So yeah, I actually I took the charging port off this old DSi XL, so that actually went pretty good, pretty easily. Yeah, this will have to set aside for another day. And let's go ahead and take a look back at this. So I'm kind of wondering, because we need to know which one is ground and which one is voltage. I think if we took continuity here, and if this pin all the way to the right is not, if it's not on ground, then it should be the voltage, and vice versa. We could do the same idea with these JST connectors, because these are small, but they'll carry enough, like 5 volts, no problem. There's a male version and a female version. Then we could solder a leg here and here. I think, but the thing about it is do we want to take this off, or do we want to do something like a dual port? Is it silly to have 2 USB ports? What would be the benefit to having 2 USB ports? Would there be any? Should we not even attempt this? Should we just to see if the battery terminals are fine? I mean, that's a possibility. We might be making a lot of headache and problem for ourselves. But if the batteries work, then that's great. If they don't work, then we'd have to have USB-C for the convenience. And if all else fails and this thing is completely destroyed, I would sit in a corner and cry. So there's always that. Let's see. Nothing ventured, nothing gained, I suppose. Let's try it. Got Steven in continuity mode, and we're just going to beep. So now this will tell us where these probes will go. Now we could grab a USB micro cable if I could hunt for one, and maybe that would help us, but we're just going to try this first. So is this right one ground? It's not going anywhere. Okay, this one goes to the resistor. What about this one? Let's see. I think this should be ground right here. No? Oh, okay. It's a little bit difficult to get these probes in here. You know what? I just had the idea of this might not work out, because thinking about this logically, this is not charging anything. This is providing power. I'm assuming we want 5 volts. I think we need to find a micro USB cable just to help us out and figure this out. I'm gonna find one and we'll go from there. All right, I was able to locate a micro USB cable, and we're going to just test some things out and figure this out as we go. So we got a USB amp meter. This will tell us how many amps it's drawing and see how many we need. Not that this is necessary, but you know, when you got the tools, use them. 5 volts, obviously, and nothing drawn. So now we're going to just go ahead and plug this thing in. This goes one way. This is why USB-C is like so nice sometimes. Oh, all right. Let's just turn it on and see if it, okay, it does power on, good. And then we're getting to draw still almost 5 volts and 0.017 amps. So now let's go ahead and grab Stefan again and do some measurements and see if we can tell what is what. I know this might be simplistic to some, but I am still learning this. So 20 volts DC sounds intelligent, and we're going to set them right here. So let's just try the red probe here and then black probe on ground. Nothing. What about over here? Nothing. What am I doing wrong? Is this ground? No. Is this ground? Okay, so we're getting almost 5 volts going into this do flippy here. I don't know what it is. So we got that, and we're getting a negative number. Okay. We put it here. We're not getting anything. So if we take our probe and put black on here, we should have a positive number, and we do. So then I think we've figured out that the left pin here is voltage. Now we have to figure out what's ground. I think this one's going to be ground, but I'm not 100% sure. Let's go ahead and disconnect this so we don't have any power coming in. And so I think this left side is going to be voltage. So we're going to mark this. We're just going to put a V and then put that there. There we go. Okay, and then I'm wondering if we have our ground on this right side, but I'm not 100% sure. I'm not getting any continuity, so let's go back to the continuity and we'll test out and see if we can figure this out. So we have ground here, right? So where's ground? Is this ground? No. Is this ground? No. Nothing is ground. Is this ground? Why aren't we having any ground at all? That doesn't make sense, does it? Is this ground? No. So now I assume, unless I'm mistaken, that this metal sheathing on this USB port has to be ground, right? I mean, that makes sense. It's usually what the deal is. Or maybe not. Maybe, okay, so this has got to be ground, right? Do we have any, let's see, do we have any markings on this to find ground? I know this might be a little silly. I mean, we can use our intelligence. This has got to be ground, right? I mean, this makes sense. We're not getting any beeps at all. Interesting. So we got this over here. So this is plus. So that's going to be voltage, and this has got to be negative or ground, right? I mean, I know what the difference is. I know that there is a difference. There's a difference between negative and ground. But does that make sense? If we find on here, this has got to be going somewhere to ground or what we need, right? Well, let's go in there. Does this go here? Why isn't this lighting up? Okay, this has got to be ground then. So we have this, what is this? Test point 2, I think? I think that's test point 2. I think that makes sense on that silk screen. What? Okay, well that's confusing me. This left side here, this first pin is going to this test point. So does that mean that test point is ground or not? Maybe if I looked up a pinout for micro USB and see if that makes sense. Let's try that. All right, so I figured out something myself and used my brain, used Teflon, the multimeter, and I think I figured something out. So setting the probe to 20 volts, because I was getting a voltage on one probe, and I was having trouble getting a voltage on that first probe, but I knew there was a voltage there. However, we just take our probes, and plug this back in, so we've got this on to voltage now. And now if we can just position, I need some sharper prongs, but if we put our voltages, or put our probes here, so now right now, we are getting negative 4.99 volts, so almost 5 volts. So now, if we reverse these probes, so red is on the right, and then we put this here to here, we are getting a regular voltage. So I don't know, it would be a positive voltage of 4.99-ish, so 5 volts. So that is right. Now, because we reverse the probes, they're on the right ones now. So the right is positive. So now it's matching up with the right. So the right should be positive, because if we reverse this and the red is now on the wrong probe pin, we get negative numbers. Because I've done this with a power supply, and this is how you can tell what's positive and what's negative. So the right side should be our positive voltage. If I'm understanding this correctly, it should be positive voltage. The left side is negative. Now, is the left side our ground? Is that what we do? Does that make sense? Are we overthinking things? Probably. But let's see. Can we find out where else would ground be is the question. That's a good question, I think. So where else would ground be? So capacitors are grounded, right? Does that make sense? So if this capacitor, we'll put Steven back into continuity mode. And this capacitor beeps when we touch this probe here. So this should be negative here on these little square rectangle boxes, right? Aha! And this is not going to beep over here. So I think we found it. It's kind of funny because this is pretty much the same way as that DSI. So what we can do is we can use some hot air to take this port off. So we'll probably solder a red wire here and a black wire here, and I think that should give us the full voltage. Now, is this going to work? Probably. I think it should, hopefully, if the technique is good. But is it necessary? I really don't know, but that's okay. You know, because could this work? Is this looking better than it was? Yeah, but it could be rusted too, so it's still looking a little bit dark. But we'll leave this in here for a long time. All right, so I think we got an idea of what we can do. We're going to go ahead and switch out to the microscope, and we're going to desolder this port off, and then we'll solder some wires up. And that's really what we'll have to do. We can solder some wires onto this, just matching the wires here. So we got to make sure that this red one goes here, and this black one goes over here. And then, you know, that's all the soldering we'll have to do. As long as we can get this port off, then we can come inside and we can work on widening this hole for the USB-C. And then probably glue this to the case, maybe. And then this piece will come off because we can break the connection in the center instead of just having the one continuous wire. Because if we had one wire, we would not be able to get this apart again. So I think that makes sense, and we'll see if the battery terminals will last and will be okay. We'll probably soak this for quite a while, and we'll come back to it. So I'm going to try something new, recording in the garage. I have a little fume extractor going. It's a little bit more beefier than the, fan on a charcoal filter. So, and yeah, let's go ahead and switch out there.
Sadly, the audio did not turn out right. It was garbly and not staticky, but high-pitched whine, so something was giving it some interference. So we got the hot air gun at 450, probably about 70% airflow, and I probably should have just wiggled the port, but I didn't think to do that, and I thought I was having some issues, and it really wasn't looking quite right. And it probably was right, but that's okay. I am still learning and trying to grow an experience. So I thought, you know what? I've seen some YouTubers flip the board around and use the heat from the back, and then the port just kind of falls out. So momentarily, we will flip it over and see if that works. And you actually saw us a little bit of flux heating up here, but still we'll flip it over. And then heat it from behind, and this is supposed to just fall out, right? Right? Possibly? Maybe? Well, let's flip it over again. And then I realized, well, gee, this board is extremely hot. What happens if I just kind of pull at this with a tweezer? And bada bing, bada boom. Pop, right off. That was out that extra heat, so I heated this thing up real hard, real bad. So I think my tip might have been oxidized a little bit, but we got to get these tiny little connectors soldered up. The wires aren't that bad, but these connections are pretty small. And my Achilles heel is perfectionism and overthinking things, and it feels like I get it soldered and then I have to rework it like 5 different times. But just got to get this black one on. And there we go. Now this is probably perfectly fine, but we got to fuss with it. Oh, that looks a little too close to the other contact. Let's move it a little bit more. Oh, no, it's really bad. No, right there. Right there, right. Solder down. Oh, no, that moved too much. Oh, right here. Let's move it back here. Solder this up here. Perfect, right? Wow, it's a little close on that right side. And how is it stable enough? That's exactly what's going through my mind. And then I'm like, you know what? Maybe my tip is oxidized, perhaps. And maybe that's why I'm having so many issues. I don't know. So you know what? I'm like, okay, well, let's do a little bit of a look-see here. Does this look okay? And even better, does it feel okay? Well, this red one doesn't seem to be moving, but this black wire looks up right there. Oh no, it's moving a little bit. So, well, it must be a bad connection then, right? And we're going to add some flux and just make sure that we got this connection all good and dandy. Because that black wire definitely looks a little bit suspect. We don't want this thing coming off. Now the problem with these wires is the force of pushing them on, and they kind of pop off because there's nothing to hold them on, so they kind of just keep popping off. All right, attempt number 2. Maybe we need some more solder. Maybe right here a little more solder. That just came off. Oh, put it back on. Nope, that's way off. That just popped up. Let's try it again. There's some tweezers holding the wire, perhaps. Let's try it again. Steady. Nope. Up. And then just splayed across. And now we have thoroughly messed up the wire. So, but at this time I'm like, you know what? Maybe it's the wire. Maybe that's the problem. Maybe it's not me. Maybe it's not my soldering skill. Maybe it's the wire. So we're just going to go ahead and desolder this black wire and try again. And right off, clean the pads up, and let's try again. And I thought to myself, well, maybe we need some more solder on these pads. Maybe that's the problem. That's the perfect amount of solder. No, I just have to clean these up, make sure they're not touching. And there. Is that enough solder? Perhaps, perchance. Now we can come out here with the tweezers and hold the wire down, maybe. And these wires are pre-tinned, so I thought about that too. Let's just try one more time. Come on. I need a PCB holder. Okay, that one should be soldered on, I hope. But of course it is not quite there. It's holding on by a wing and a prayer. Just a little bit more fussing. This is like rocket surgery. Splayed again. Maybe if we twist the red wire up a little bit, maybe that'll help. We're not giving up yet. It really didn't do much for that wire, but right about there, I think we are connected okay. Does it look good? Absolutely not. But will it work? Maybe. Then we just got to get this black wire soldered up. As soon as I let go of the force on the soldering iron to the wire, it just pops up. And there we go. Is that good? Maybe not. We'll see. A little bit of wiggling, and it looks okay. Oh, no, it just moved. So now I'm thinking, all right, this wire is not quite soldered on like this other one. This other one seems to be perfectly fine. Although it might be soldered to that test point. I wasn't 100% sure. But this black wire definitely needs to be redone. Surely this wire won't pop off. Yep, and building up quite a substantial lump of solder on that ground point or whatever it is up there. Maybe it was an anchor point, I don't know. And here we go, another attempt. This one's getting splayed. It's okay, we're not giving up quite yet. There we go. And it looks solid. It's not really moving around at that point. Now this should be perfectly fine. However, I'm like, you know what? This needs a little more solder here. And then I thought to myself, gee, that black wire, is that black wire right? Is that really right there? I think so. It should be good, right? Yes, it's good. Okay. Now we put our attention to All right, now we have to look at this USB-C breakout board thing. Now, I have a question. If you guys know, could I have just soldered the ground point on the right there to ground on that board? Or would that not have been a good idea? Then I thought to myself, you know what? Maybe instead of working on this board first, we need to clean that flux off. Because you know what? I've, to be honest, just started to realize the flux I've been using could be corrosive. And also, it does kind of look like those are bridging on those points, but I'm not 100% sure. The black wire could be touching those other ports. Same thing with the red wire. So we're just going to hit these wires up a little bit more, just a teeny hair bit more, just to make sure we do not have any problems. I thought there was more pins than there was, but there we go. We'll move that over to the right a little bit. Of course, this red one looks like it could be touching the left side, but it's really difficult to tell. Probably could have zoomed in here, but I decided to go ahead and just, look at it a little bit, look at it a little bit more. And then I said, you know what, it's fine. Let's just clean this flux off, because I guess the flux can be corrosive and eat away at things. And I didn't understand that quite as good now as I do now. And after a thorough scrubbing, it should be okay. And now let's jump right back to that USB-C breakout board. Now again, can we just solder ground wire to that G there and then just figure out what plus voltage is? Does it have to be a ground on that where that port is, or could that ground go anywhere on the circuit board? Let me know if you guys know. I also decided that, you know what, these pads could probably use some flux and some more solder on them. So we'll just apply a dab or two of flux over these pads, and that'll help everything stick together and become molten and not go anywhere it shouldn't. And now we can just add a little bit of tiny bit of solder to these pads and make sure the wires stick really good. It's not quite flowing all the way, but there it goes. And same for this ground point, and there we go. And we do not need to mess with the digital plus and minus. That's if you want USB connectivity, file sharing, connection to computers, that kind of thing. But we do not need that for this. Alright, let's go ahead and solder these wires up. We'll start with the ground after we do the voltage, apparently. We just connect red here. Make sure it doesn't stick out too far. Make sure it's all connected. And then we can do black here and just kind of molten the solder up and stick it into place, and hopefully it all gets melded down. There we go. It should be good. Should be okay. Looks okay to me. That blob there we can suck up. And there we go. And we'll clean. And you know what? Just a little bit more fussing. Maybe it just needs a little more heat, and push it in and keep working at it, and then realize we messed up and do it again and let it flow again, and then say, okay, good enough. I'm shocked I did not mess with that left side. But we're done.
So let's go ahead and take a look at our battery contacts here. How do we look? It looks dark. We'll see if it has continuity. It looks like the nickel plating has been removed. Any more rust on there? Looks okay. Let's try the continuity. Okay. Looks pretty good, actually. Of course, we gotta fix this part too. Let's go ahead and get this USB-C fixed up too, because we took the port off. So we gotta put this in here. So we need not a huge amount of space, just enough. I think I'm gonna use we got some needle files here, and see if these work. Na-na-na-na-na-na, na-na-na-na-na-na. So how are we looking so far? Okay, it's not horrible. Still need a little bit more. Okay, keep trying this, do a little test fit, and we're getting pretty close. Oh, there we go. I think we want it to be about about there. That makes sense. So we're gonna just go ahead. I think what we also are gonna do is take some tape, and that should be reasonable. Should be good. Now we're gonna grab some glue. I used this Gorilla Glue on this DS case, and it is really solid. So should be good to go with. So we're going to let this set up and solidify, and then we will test everything out and see how it goes. We'll go ahead and even add a little bit to this and see how this goes. It's the next day, and the glue has set up. And we have a pretty solid connection here. It's not really wiggling very much. Let's go and remove this tape. And that looks pretty good, I think. And let's just test it out real quick. Add a USB-C cable. It fits in there. Doesn't look too bad. Pull it out. Put it back in. Oh. That pushed it through a little bit. All right. Yeah, we'll have to add a little bit more glue. I think the problem is it tipped over, so a lot of the glue pooled up down here. So we'll just add a little bit more glue and retry this. That's okay. We're still learning this. We're still trying to figure this out. We're going to put this in front of it. That way it won't tip over again. All right. It's been maybe about an hour, if that, and we're not quite solidified yet. But it's pretty sticky still. But we're just going to go ahead and be very, very careful with it and test it out and get this video buttoned up. Got our membrane. We've got our board here. Let's go and pop this forward a little bit. And we got to put this down like this, I think. Are we missing more buttons? No. Oh, must just been a feature. Put these out of the way. See if I can push this down somehow. All right, let's go ahead and grab our screws. And Mobo is first. Just gotta screw up here. Wait a second. That doesn't make sense, does it? How do we get these screws in here? Wait, does this thing get screwed back into here like this? I have completely forgotten about that. Right? Wow. I'm completely blanking on how this thing goes in there. It's gotta go like this then, huh? Yeah, because we got the screw holes here and here. I did not think about that. Alright, so alright, what we need to do then is reconnect this battery terminal thing. I remember that being under there, I just forgot about the other part. And then we need to connect this dude to this part. Red to red. There we go. Alright, now we can maneuver this dude into place, right? Okay, so we put this over here. And then we gotta get this thing set up here. We got this upside down? Yeah, that's what it is. We got this upside down. Aha. Intelligence. Alright, now let's try getting a screw in here. Okay, there's one screw. Let's go ahead and get this other screw in. Let's go ahead and get this other screw in up. Okay, and then we gotta get this third screw in here. And then there's one more screw down at the bottom right. And there we go. Now we gotta get this rubber membrane in the right position. Make sure that's oriented the right way. We need to put this in here and push this up into here. Hopefully gravity will help that stick on and not just come right off. Okay, looks okay to me. But what do I know? Alright, gonna get the case screws back in. And there we go. Let's see, let's see if this thing will work. Oh, no, that just broke off. Oh well, that will not be reused. We'll have to figure out if I can figure out where that went. Alright. And it is time. It is time to test. Let's grab some test batteries. We'll need 2 AA batteries to test. Did we mess anything up or did we fix it? Three, two, one. Oh, it's got life. Hallelujah. It's got life. Does it zero out on the measurements? We really don't have a I don't know if we really have a capacitor to test, but we'll see. If it zeroes out, we should be okay. So let's go ahead and put ours together and zero. Oh, it's got something there. There we go. 0. There we go. It zeroed out. Now, That's half the battle. So that's good. At least it's working now. So let's go ahead and take our test batteries out. Now for the real test. Place your bets. Did we do it right? Oh, we did it right. It's working. It's working. Woohoo! Yay! Let's see. Should get a 5 something or others. Yep, 5.68. Down to 0.3. I guess that's normal. Zero it out. Bada bing, bada boom. Very nice. Alright, and we have a game we can just check out real quick and see if this is fully working. Royal Rumble for the Sega Genesis. Here's the board, and it is working. We got a capacitor here, and this one is a 16 volt 47 microfarad. Yeah, 16 volt 47. So if we look down here, we got what is this? 4067? What is this again? 47 UF, which is microfarad, and we are at 6 volts. Is that right? Or 16? 16 volts, 47. Okay. 47 UF, 16 volts should be 1.6. So reference for 25 volt E cap, good with cap. Okay, so I'm going to zero this out one more time, pop these off, and we are going to do one here on this back side. I think will be the best way to get to it, and one right here. Hopefully this doesn't interact. Okay, 0.871. Good if cap is 200 UF. So I'm assuming if it's if this measurement is more than 1.6, it's bad, but if it's lower than 1.6, it's okay, because we're getting 0.806 or 60, and this capacitor might be okay. Yes, good if cap is less than 200 UF. So it is, because this is supposed to be a 47 UF cap, and it is lower than 200, so we should be okay. I think this makes sense. If you guys know more than me about this stuff, please let me know. We might have gotten a bad reading. Let me try from here too, just for grins. I don't know if this will work or not. Nope, same reading. It's 0.841. So still reading, still good. I think that's good. Now turn this off, and there we go. We have a USB-C ESR meter. So that actually worked out pretty decently. And we can definitely add that to the tool belt of fixing something that is micro USB over to something completely different. We did break this. I don't know if I'd be able to fix this at all, but that's okay, I guess. C'est la vie. And that should be good. Thank you guys for watching. I hope this video was at least helpful to somebody. It was at least fun getting that USB-C working and cleaning the battery corrosion off, and hopefully we will be able to use this in the future, but still I definitely need to learn how to use this. I think I used it good, but by all means let me know in the comments if you know more about this stuff or this meter than me. Thank you guys for watching, and God bless.